Hello students, how are you all? I hope you all are doing well. So students, in previous class I completed the chapter limit of function, right? Now from today's class I am going to start the chapter continuity. Continuity. And I think this is the third chapter of differential calculus, and I already told you it is a very important question, limits of function, continuity of function and differentiability of question. From these chapters you got lots of question in your JEE Mains examination, right? So be concentrate. First of all I want to give you a basic idea of what is continuity, right? So don't write anything. What is continuity? Basic idea. Now what is the word meaning of continuity? Tell me anyone, what is the word meaning of continuity in your real life? Exactly. Continuity means without any break and without any gap. Okay? Without any interruption, without any gap. We can say that continuity means without any gap or we can say that without any gap, right? Now in your real life continuity means continuous, means without any break, right? But the same thing is happened here in the language of mathematics. If I want to say if you take a function, right? Now if you able to draw the graph of that function, then in the graph if there is no gap, means there is no gap, then we can say that the given function is continuous, right? If there is no gap in the graph of the function, then that function is known as continuous function, right? So write down, if there is no gap, if there is no gap or no break or no any interruption in the graph of the function, then that function is known as continuous function, right? Now what's the definition says? Let us take an example. First, sin x. And I already told you in the chapter number 1 how to draw the graph of sin x. So everyone, each and every student draw the graph of sin x. This is x and this is fx, right? How to draw the graph of sin x? This looks like that, right? Now in this graph, is there any gap or break? Tell me anyone, any gap or break here? No. Okay, so we can say that the given function means sine function is continuous. Similarly, if we draw the graph, example 2. If we draw the graph of cos x, fx is equal to cos x, right? How to draw the graph of cos x? This looks like that. Right? Now you all can observe here, the graph of the cos x is also has no any gap or no any break, right? So this graph, this function fx is equal to cos x is also a continuous function. continuous function. Right? Now I can take another example. Example 3. If we take fx is equal to mod x, and recall the chapter number 1, elementary mathematics, right? Mod x, where I can already told you the property of modulus of x, right? Now draw the graph of mod x. How to draw? Recall chapter number 1, functions, x and fx. The graph of mod x will be, this is looks like that, right? Now you can observe the given graph is also has no any gap or interaction here. So we can say that the modulus function is also a continuous function, isn't it? Now similarly x square, x, sin x, cos x, x cube, all are examples of continuous function. Okay, so this is all about continuous function. Now the question arises, what is discontinuous function? So simply we can say that discontinuous function is that function whose if we draw the graph of that function, then there is a break in the graph, isn't it? If there is a gap or break in the graph of the function, then that function is called the discontinuous function, right? So write down, while I use this side of board, while mod x, greatest integer function 1 by x, all are examples of discontinuous function. Right? Because greatest integer function, I already explained, greatest integer function is discontinuous at every integer, right? If we draw the graph of 1 by x, fx is equal to 1 by x, then this looks like that. Okay, so this graph is discontinuous at point, which point? Tell me anyone? Exactly, this graph is discontinuous at x is equal to 0, right? So we can say that 1 by x is discontinuous at 0. Okay, similarly tan x is also discontinuous. Why? Because if we look from minus pi by 2 to pi by 2, the graph of function is continuous, tan function is continuous, but after pi by 2 there is a break in the function, right? So this function is also an example of discontinuous function, isn't it? Now this is all about how to decide the continuity of the function by seeing the graph only, right? Now but there is a very interesting point. What if the function is very complicated, right? If the function is very complicated, then how to draw the graph of that function and how to decide the continuity of the function, right? Because lots of functions are there whose graph is not an easy task to draw, right? So how to decide the continuity of that function? Is this function is continuous, this function is continuous or not? Okay, so I am going to explain how to decide that type of function and how to tell about the continuity of function, right? So First of all, I want to take the function whose graph is already known, right? Now take fx is equal to example 1. I will take 3 examples. I take 3 examples, and through these 3 examples, firstly I want to explain you how the discontinuity occurs, right? So we concentrate on both. Fx is equal to, take a function x square minus 1 upon x minus 1. Okay, this is a function. After simplifying the given function, we can obtain x minus 1, x plus 1. Recall the chapter number 1, elementary mathematics, right? So this is a very important formula of a square minus b square, which is a plus b and a minus b. So here we use the formula of a square minus b square, right? Now x minus 1, fx is equal to x plus 1. If we draw the graph of the given function, then it is very easy to draw x and fx. 0, 1, 2, 3, minus 1, minus 2 and minus 3. This is 1, 2 and 3. Right? If we draw the graph, then this looks like that. Why we have put this? Because you can see that if we put the value of x in the function, then given function is undefined, right? Given function is undefined, x is equal to 1, means x is equal to 1 point is not in the domain of the function, isn't it? Means x is equal to 1 is not in the domain of the function. So the continuity occurs because x is equal to 1 point is not in the domain, and at x is equal to 1 there is a gap in the graph. You can observe there is a gap in the graph, and if you conclude that the graph is not continuous because there is a gap in the graph, then we can say that the given function is not continuous, means the given function is discontinuous at x is equal to 1, isn't it? Means here discontinuity occurs because the point 1 is not in the domain of the function, right? So first condition is that. Similarly, I take 2 examples after that. There I can explain how the discontinuity occurs, right? So this is discontinuity at point 1. So what's the reason of discontinuity? Discontinuous at x is equal to discontinuous at x is equal to 1. And reason क्या है? Reason is x is equal to 1 point is not in the domain of the function. Point is not in the domain of function. Right. Now I am going to take other example from which we can see that how the discontinuity occurs. Example 1. This is example 1, and please keep in your mind this example is very important, because from after this example I am going to explain the definition of discontinuity and how discontinuity occurs. Right. Now example 2. Let us take a greatest integer function, and I think you all know that how to draw the graph of greatest integer function, because I already explained in the limits of function chapter, right? So every students in this class draw the graph of greatest integer function in your notebook, right? Let's draw. Fx is equal to greatest integer function. If we take x and here fx, 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 1, 2, So students, you all know that discontinuity occurs at every integer, right? Every integer, the greatest integer function is not continuous because there is a gap. Let's see how this gap arises. This looks like in that way. Okay? This is the graph of greatest integer function, and you can observe that if we take an integer x is equal to 1, then left hand side, the value of left hand side at x is equal to 1. If we approaching towards x is equal to 1 from left hand side, then what can I observe? The value of fx is just slightly lesser than the 1. Right, you can observe students the value of x if we approaching from left hand side of towards 1, then the value of 1 will be just slightly lesser than the 1, right? And if we approaching towards 1 from right hand side, then the value of 1 is just greater than 1. Okay, recall the limits of function chapter, where here we can observe that the left hand limit and right hand limit is not equal, right? You can observe students, left hand limit, if we approaching towards 1 from left hand side, then we can say that the value of fx is just slightly lesser than the 1, and if we approaching towards right hand side, then the value of fx is just slightly above than the 1, right? So this is the reason of discontinuity, why the discontinuity occurs. So this is the other reason of discontinuity. There are three reasons of discontinuity where I am going to explain. So first one is if the x is equal to 1 point is not in the domain. This is the first reason. And here if the right hand limit and left hand limit is not equal, then discontinuity occurs, right? Which is already seen in the fx is equal to greatest integer function, right? So the reason of discontinuity, you can see that the graph is not continuous. So by graph idea, we can say that the given function is not continuous, isn't it? Now here discontinuity at every, tell me anyone, discontinuity at every integers, right? Discontinuity at every integer. Okay, and reason of discontinuity, why discontinuity occurs? Reason, because left hand limit and right hand limit at x is equal to 1 is not equal, right? Left hand limit is not equal to right hand limit, and if this condition occurs, then what we can say, that the limit does not exist, right? Limit does not exist. This is the second reason of discontinuity, why the discontinuity occurs, right? Student, this is a basic idea how to approach and how to go through the definition of continuity, right? So this is the discontinuity. This discontinuity occurs because function is not defined at x is equal to 1. This discontinuity occurs because left hand limit and right hand limit are not equal, means limit does not exist. Now I am going to take third example in which other type of discontinuity occurs. Suppose I am taking example 3. Fx is equal to a function x plus 1 and 3. This is if x is not equal to 1, and this is if x is equal to 1. Right? This is a function. Now I am going to draw the graph of the given function. This is x and this is fx. Everyone in your notebook draw the graph of the given function, because I already explained in the function chapter how to draw the graph of such type of functions, right? In this way we can draw the given graph, right? Now you can observe that this is a discontinuous graph, right? Because there is a gap. But at x is equal to 1 here, this is not the reason domain in the x point is in domain. But at point x, the value of the function is at 3. You can observe that, students, it is very important. If we observe here the value of the function at point 1, by observing the given graph, the value of the function at point 1 is 3 here, right? At point 1 the value of the function is 3. If this point is fill this gap, then we can say that the given function is continuous, right? So the reason of discontinuity, why here discontinuity occurs? Because the value of the function is not equal. Here left hand limit and right hand limit are equal. Why? Because if we approaching towards 1 from both sides, then this is approach towards the 2. Right? So left hand limit and right hand limit are equal, but the value of the function at point 1 is not equal. If the value of the function at point 1 is equal to 2, then we can say that the given function is continuous, because here then we can say that the function is continuous, but here at point 1 the value of the function is at 3. Right? So this is the reason of discontinuity. So I explained 3 discontinuity reason why discontinuity occurs. Now I am going now after that I go on the definition of continuity, right? Here left hand limit and right hand limit are equal, but the value of the function is not equal. So discontinuity, because limit x tends to 1, fx is not equal to f of a. Okay, so there in today's class I explained 3 reasons of discontinuity, how discontinuity occurs. Now in next class I will discuss definition of continuity, right? So thanks for today's class.